practice we going to evaluate the characteristics and of an welding steel. Also, we wanna do a metallographic study of this welding steel. In the experimental procedure, we welded two metal plates, like is shown in the figure. We do the metallographic preparation of the two samples coated. For this, we use the mounting press for metallographic specimens. Then, in this mounting press, we add bakelite to have our piece. In this step, we maintain our pressure in the red zone, as is shown in the picture. Then we polish our piece with the machine. After that, we do a chemical attack and apply alumina. After that, we are going to proceed to the micro hardness test. This means hardness beakers. For the beakers hardness, we use a beakers durometer. And we also going to need a metallographic microscope. In this step, we have our results about the hardness of the two different pieces, and we are going to compare them in our analysis.
As we saw earlier in class, we know that alloys and pure metals have different properties. And in this case, in this lab, we welded two pieces of steel, and as we know, it's an alloy. So when we raise the temperature in alloys, we increase the strength of the material and also the creep resistance.
In our results of the beaker's hardness, we observed that in the welded steel we have a large difference between the results, and in the normal steel without welding, we can see that the difference range between the results is not longer. We think that this is because the welded material is more irregular than the normal steel. Also, this difference can be seen in the next image of the grand size.
We can see in our results the welding zone have a considerable increase in hardening that could put in danger the application. For example, if we receive a bigger effort in that zone, our piece could break or could start to break, and we don't want that. We don't want that for our pieces. So if we really need to use welding in our pieces, we have to use with extremely careful and just in places that are necessary.
We have two main disadvantages in the welding process. The first one, it's called hot sharpness, which is produced by the highly increased temperature to the moment to do the welding process, and this affects our material. And the second one, it's microsegregation. This is due to the use of different materials. One, it's going to be our steel, and the other one is the welding material that we're going to use. A pro of using welding process is that we can have initially joined two or more different pieces just by doing this simple process. In the welding process, after the joint, we can have we're going to see smaller pieces of grains, the closest to the joint, and this is going to make our material more brittle, and this is one of the disadvantages that we're going to have in this kind of process. It's going to change its mechanical properties, and as we can see it in the diagram.
The hardness changes that we have that are applied on our weld are present in the test in the Vickers test. Another property that changes is the resilience of the test of impact, since it is reduced to the applied weld. When welded, it is likely to suffer cracks in it or on the weld itself. It's what it changes when welding is applied in our piece of metal. And how does the arc welding with coated electrode works? It's mainly because it's one of the easiest processes that we have to have a better aesthetic and metallic result. It is necessary also an arc generated by the electrode by the edges of the piece to be joined. The electrodes are composed of a metal core whose diameter defines the nominal gauge, and by an outer coating obtained by pulverized substances bound by a bender and kiln dried. The center conducts the electric current that feeds the arc and supplies the material that will constitute the core of the weld of our piece. It reacts with the melted by modify the mechanical properties, and it ionizes the arc and keeps it stable. It was appreciated in the analysis of the results that with the welding we had a much higher strength, weld hardness, Vickers hardness, that we had an average of 180.3 Vickers hardness and a maximum of 204. And without the welding, we had an average of 171 Vickers hardness and a maximum of 175. It's more stable in the part that is not welded, that in comparison with the part that is welded, because it has pikes, like it goes higher and lower from the normal, that is the normal steel, but it also enhances its hardness but decreases its mechanical properties.
This lab gave me the opportunity to apply the theoretical learnings of class in the lab, and I also liked that we reviewed information and procedures from the last class of materials, which was really nice. And yeah, I had a really good time working with my team in this lab.
As a personal conclusion, I can say that for this kind of process that we need to weld two parts of steels in this case, it's something that is going to be critical but really useful in the industry, because the union of two pieces that we need to be together to have a specific function for something to be applied. As for example, in the automotive industry, we can see that in the door hinges, there always a weld applied over there, that it can make our material or steel or aluminum probably softer or harder in certain parts, but it will make a perfect union to make two pieces work together to have a specific function that is different. So it's really important, this kind of welding, that is properly made by a machine or by a technician, so it complies with the policies.
In conclusion, the welding process is very useful. We just want to join our different materials, but we need to see and analyze what is going to be the application for the final product, because we shouldn't use this kind of process in real critical pieces.
I can say that this practice is so useful for the application of the material, in this case the steel. We learned that the change that the welding of steel and the normal steel have, and this is useful to know the characteristics of this material.
My conclusion of this practice is that the welding affects too much to the microstructure of our material, and that is a very important factor to consider in the application that we are going to use. My point of view is that we have to design the pieces of one way that we don't have to use welding to put in danger or pieces.